There are a few more elements that we won't get to today, but we will get to in the future.
Elon Musk once said there are a few more elements we haven't talked about yet, and he wasn't joking. That cryptic remark was more than just a passing comment. It was a signal to those paying attention that Tesla's next revolution won't come from lithium, and it won't come from solid state. The element he was hinting at is aluminum. And in 2026, it's set to power a battery so advanced, so radically efficient, that even Tesla's fiercest competitors are calling it impossible. But the future isn't coming years from now. It's already here. Meet the Omega Core, a new generation of energy storage that can drive a Tesla for over 100 days without charging. A battery that rewrites every rule of physics, destroys every old limitation, and turns today's EV technology into yesterday's news. Today, we're going deep into the science, the breakthroughs, and the insane possibilities that make the Omega Core the single most important battery ever designed. So buckle up. What you're about to hear will change the way you think about energy, cars, and the very future of technology. When we talk about batteries, the most important factor isn't just size or cost, it's energy density. How much power can you actually pack into a given space? That single metric decides everything. How far a car can drive, how fast it can charge, and how long it will last before the driver ever needs to plug in again. For decades, lithium-ion ruled this game. From your smartphone to your laptop to your electric car, lithium-ion cells were the silent engine of modern life. But the truth is, even the best lithium packs are starting to hit a wall. They can only push so much energy before overheating, swelling, or breaking down entirely. Engineers have spent billions trying to squeeze out just a little more capacity, but physics itself has become the barrier. And that's where aluminum enters the story. At first, it sounds almost too simple. Aluminum is everywhere, in soda cans, airplanes, and skyscrapers. But hidden in plain sight is its greatest secret. It holds nearly twice the charge potential of lithium when used in the right configuration. Unlike lithium, which is scarce and expensive to mine, aluminum is the most abundant metal in Earth's crust. It's light, it's cheap, and it's already part of global manufacturing at massive scale. That means if it can be turned into a high-performance battery, the supply chain is already solved before the first car even rolls off the assembly line. The Omega Core taps into this hidden advantage by using a layered aluminum-ion structure. Imagine billions of aluminum particles stacked with ultra-thin graphene sheets. Together, they create a kind of expressway for electrons to move through, avoiding the traffic jams and bottlenecks that plague lithium cells. And here's the shocking part. These aluminum-ion highways don't just improve efficiency, they practically eliminate the risk of thermal runaway. In other words, no dangerous overheating, no fires, no catastrophic breakdowns. The result? A battery with up to 200% the energy density of today's best lithium packs, and with stability that makes it almost indestructible under normal conditions. That means longer driving ranges, cars traveling over 1,000 miles on a single charge. It means safer rides, with less risk of sudden failures. And it means energy storage systems that can finally keep up with the demands of an all-electric future, from cars and planes to entire power grids. And here's where things get even more interesting. While lithium is showing its limits, aluminum is just beginning to reveal its full potential. If energy density decides how far you can go, then charging speed decides how free you really are. Because let's be honest, what good is a 1,000-mile battery if it takes half a day to charge? That's been the Achilles heel of electric vehicles since the very beginning. Lithium-ion packs can only absorb so much current before they overheat or degrade. Push them too hard, and you shorten their lifespan dramatically. That's why even the fastest superchargers still leave drivers waiting for 30 minutes or more to get a decent top-up. But aluminum doesn't play by those rules. Its unique chemistry allows ions to move in and out of the electrodes far faster, without the kind of stress that wrecks lithium cells. In lab tests, Omega Core batteries have been recharged to 80% capacity in less than 5 minutes, a number that sounds more like filling up a gas tank than plugging in an EV. And here's the twist. This speed doesn't come at the cost of durability. In fact, aluminum-ion cells show virtually no capacity loss even after thousands of rapid charge cycles. For drivers, that means not only charging in the time it takes to grab a coffee, but also keeping that same performance for years without decline. Imagine a world where you stop for a few minutes at a charging station, stretch your legs, and by the time you're back behind the wheel, your car is fully ready to go. No waiting, no stress, no compromise. If charging speed changes how you use your car, then durability changes how you own it. Because until now, every EV owner has lived with the same quiet fear that one day, their expensive battery pack will fade, forcing a replacement that costs nearly as much as the car itself. Traditional lithium-ion cells degrade over time because of structural stress. Each time they charge and discharge, the crystal lattice inside expands and contracts, breaking bonds bit by bit. After a few thousand cycles, capacity drops, range shrinks, and the car that once felt limitless suddenly feels fragile. But Omega Core doesn't degrade in the same way. Instead of relying on chemical bonds to store energy, it uses a vacuum graphene lattice where energy is held as quantum states. That means every charge cycle isn't a physical strain. It's just an adjustment of electron states. The result? Practically no wear and tear, even after decades of use. Lab data shows that these cells can endure over 11,000 full cycles while still retaining more than 90% capacity. To put that into perspective, at the Model 2's projected 400-mile range, that's more than 4.4 million miles of driving. For the average driver, it means a battery that could, in theory, outlive generations. Think about what that means for ownership. The battery is no longer a consumable. It becomes a permanent asset. Something you invest in once, and it stays with you, reliable, for as long as you need it. Your car stops being a product that wears out and starts becoming a legacy that you can pass on. And it's not just about long life. The stability of this system also removes the three biggest dangers of conventional batteries: swelling, overheating, and fire risk. By eliminating chemical breakdown, Omega Core stays stable under conditions that would destroy any other cell. So the question becomes, if your car could last longer than you'll ever need it to, what would that mean for the future of transportation? While most electric cars struggle in harsh weather, losing power in freezing winters or overheating under the summer sun, Tesla's aluminum breakthrough rewrites the rules. This new battery doesn't just tolerate extreme conditions, it thrives in them. Aluminum's natural thermal conductivity allows it to move heat almost instantly, keeping the cells balanced whether you're driving through the Arctic or across the deserts of Nevada. No more winter range anxiety, no more summer performance drops, just consistent, unstoppable power. But here's where things get even more unreal. The Omega Core uses what researchers call plasma conduction. Instead of relying solely on traditional electrodes, microscopic plasma channels allow electricity to move with almost zero resistance. Think about it. Electrons flowing as if on a frictionless highway, delivering power at speeds no lithium battery could ever achieve. The result? A battery that remains stable in the most brutal environments, while pushing out energy with a force so raw it borders on science fiction. And yet, it's real, and it's already being tested inside Tesla's secret labs. If plasma conduction sounded futuristic, Tesla's next move takes it straight into the realm of quantum physics. The Omega Core doesn't just move electricity through wires and electrodes. It uses a principle scientists call quantum tunneling. Imagine energy jumping from point A to point B without ever traveling the space in between. That's not theory. It's how this battery transfers power at the subatomic level. The effect? Instant energy distribution. Press the accelerator, and the response is immediate. No delay, no lag. Just raw torque flooding the motors the very moment you need it. And yet, Tesla went even further. To stabilize this wild energy flow, the Omega Core is surrounded by a graphene vacuum chamber. Graphene, one of the strongest and most conductive materials known, creates a near-perfect shield around the cells. Inside this vacuum, heat is reduced to almost nothing, and interference from outside forces becomes irrelevant. The result is a battery environment so pure and controlled that degradation slows to a crawl. Instead of replacing a pack after 10 years, these cells could last 50 or more. In other words, the Omega Core isn't just about performance. It's about rewriting the lifespan of energy itself. If plasma conduction sounded futuristic, Tesla's next move takes it straight into the realm of quantum physics. The Omega Core doesn't just move electricity through wires and electrodes. It uses a principle scientists call quantum tunneling. Imagine energy jumping from point A to point B without ever traveling the space in between. That's not theory. It's how this battery transfers power at the subatomic level. The effect? Instant energy distribution. Press the accelerator, and the response is immediate. No delay, no lag. Just raw torque flooding the motors the very moment you need it. And yet, Tesla went even further. To stabilize this wild energy flow, the Omega core is surrounded by a graphene vacuum chamber. Graphene, one of the strongest and most conductive materials known, creates a near-perfect shield around the cells. Inside this vacuum, heat is reduced to almost nothing, and interference from outside forces becomes irrelevant. The result is a battery environment so pure and controlled that degradation slows to a crawl. Instead of replacing a pack after 10 years, these cells could last 50 or more. In other words, the Omega core isn't just about performance. It's about rewriting the lifespan of energy itself. Now here's where the Omega core turns from revolutionary to almost unbelievable. This battery doesn't just hold energy, it creates its own. Using layered piezoelectric membranes hidden within the pack, the system can harvest energy from the car's own vibrations, from the airflow rushing over its body, and even from the driver's braking patterns. Think of it like a car that breathes power back into itself. Every bump in the road, every gust of wind, every press of the brake pedal becomes another chance to recharge. And while traditional regenerative braking gives you a fraction of that energy back, the Omega core's system can capture nearly 4 times more. But Tesla didn't stop there. Engineers embedded micro-solar collectors right into the graphene shell. These aren't like the bulky panels you see on rooftops. They're almost invisible, woven into the molecular lattice itself. Even under cloudy skies, they sip photons and trickle charge the battery quietly, endlessly. What does this mean in practice? A Tesla that doesn't just go further between charges, but one that could, under the right conditions, charge itself indefinitely. A machine that blurs the line between consumption and creation. What truly separates the Omega core from every other battery on the planet isn't just how it stores energy, it's how it thinks. For the first time, Tesla has integrated a neural AI system directly into the battery architecture. This isn't the same AI that runs autopilot. It's a specialized energy intelligence that constantly studies how the driver uses power, how the environment shifts, and even how the grid itself fluctuates. Imagine a battery that can predict your needs before you even press the pedal. Heading up a steep hill? The Omega core has already preloaded extra charge into the motors. Cruising down a long highway? The AI dials energy output to maximum efficiency, stretching your range further than you'd expect. But it doesn't stop there. The Omega core can also communicate with other Teslas on the road. Sharing data in real time, each car becomes part of a living, breathing network, one that adapts, optimizes, and even balances energy between vehicles if needed. This level of predictive intelligence doesn't just save energy, it changes the relationship between machine and driver. It feels less like you're driving a car, and more like the car is anticipating your every move. The Omega core isn't just a battery. It's a declaration of war against the limits of technology itself. For over a century, humanity has been chained to the idea that energy is scarce, fragile, and temporary. But what Tesla has built here suggests a very different future, one where energy is abundant, self-sustaining, and nearly eternal. This isn't just about cars. It's about what happens when the walls between consumption and creation fall away. Homes that never lose power. Cities that run without coal, gas, or oil. A world where the word charge might one day sound as outdated as dial-up internet. But here's the real question. If Tesla truly holds the key to infinite energy, how long will it stay in their hands? Will it be shared with the world, or locked away as the most valuable secret of the century? One thing is certain, the Omega core is not just a leap forward in technology. It's the spark of a revolution. And revolutions never stay quiet for long.